In the previous class, we have seen the two advantages of closure set of attributes, right? So, closure set of attributes means which are meant for to identify various kind of functional dependencies. So, one of the advantages of closure set of functional attributes is we can able to get additional functional dependencies, additional FDs. The other advantage is we can able to define whether two independent functional dependency sets are equal or not. So we can say that like whether two functional dependencies are equivalent or not. The another one is with the help of this closed set of attributes we can able to find out various kind of candidate keys in the given set, right? And one more advantage is we can able to identify the smallest set from the given set. We can call it as irreducible set. Irreducible, right? So now in today's class we will see the final advantage of closed set of attributes, that is irreducible set, or I can call it as minimal set term, minimal set, or I can call it as canonical FDs. These are the many ways you can able to call, right? So guys, the meaning itself clearly understood. If I am saying that is irreducible set means which I cannot able to reduce further. If I am saying that minimal which I cannot able to reduce further, then I can call it as irreducible set, right? Meaning that basically if client is going to give certain requirements to you, the designer will design various kind of FDs, right? So among those FDs, basically F1 set of FDs you are going to get. These are will get based on basic kind of illusions. I hope you remember it, right? And F2 is a set of functional dependencies which I can able to get through the concept of various kind of formulas, or I can able to get it through closure set of attributes. Am I right? And if I am saying that total functional dependencies, which means I can call it as F1 plus F2. So these are my final functional dependencies which are required for my database design. But if you are going to look into in depth about this total set of functional dependencies, is there any chance of having it contains the redundant functional dependencies? Is there any chance? For example, let us take the F1 contains A determines B and F2 contains B determines C, and also assume that F1 contains A determines C. Assume that A determines C. What are the total functional dependencies now? A determines B, B determines C, and A determines C. A determines C. If I are able to clearly observe from A determines B and B determines C, can I able to get A determines C or not? Yes, we can able to get, right? So I can say that this is the redundant one. So I will remove it from the set of functional dependencies. Now, is there any way to reduce this one again? No. So I can call it as irreducible set, which I cannot able to further minimize it, right? So this is the concept behind irreducible set, meaning that here before going for further process of implementing the actual database, we have to always think about various kind of redundant attributes on the LHS side. This is the first point you have to understand, right? And you have to think about redundant attributes which are present on the RHS side, and also you have to think about the redundant FDs. These are the 3 points you have to consider if you want to generate a irreducible set. I mean, if you are going to take A determines BC, you have to think about whether B is enough on the right side or C is enough on the right side, or both are compulsory required, right? So this is what the second point is defining. We have to identify whether B is redundant or C is redundant or both are required. That is what I can say, that you have to identify the redundant attributes on the RHS side. Similarly, redundant attributes on the LHS means if I am saying that BC determines A, whether B is enough to get C or C is enough to get B. Like that you have to make analyze. So simply say that in order to get any simplified solution, you have to make sure to concentrate on these 3 points. Okay, fine. So how to eliminate these redundancies means you have simple procedure is there. So by following that simple procedure, you can able to eliminate all these 3 steps. Right? That redundancies can be either on the LHS or RHS attributes or the respective FDs. So first step, what you have to do? So you can just make try to make the single attributes on the RHS side. First step is you have to try to have single attributes on the RHS side. Try to have single attributes on the RHS side, right? What is the meaning of it? Right? For example, if you are going to have a functional dependency called A determines BC, first step is for the respective functional dependency, you have to make the right side should be single attribute. Right? How can you make the right side should be single attribute? Can I say that A determines B and A determines C? Yes, I can do it, right? So by following the principle of decomposition principle, right? So because there is no problem when we are going to split like this, right? Can I get back this one again? Yes, by following the union property you can able to get back. So there is no problem with this step, right? So this is the first step you have to do. And once you did this one for all functional dependencies, at the set 2 you have to identify redundant functional dependencies. Redundant functional dependency. How we are going to identify the redundant functional dependencies? Try to take out one by one functional dependency and check their validity. Right? What is the meaning of this step? Meaning that if I am going to say that some functional dependency is a kind of a valid functional dependency, it means that I cannot able to derive that from the any other kind of functional dependencies. Then I can say that it's a valid functional dependency. Otherwise I can say that it is like irredundant functional dependency. For example, simply I am going to have these 3 functional dependencies are A determines B, B determines C and A determines C. So what this step you have to do? You have to take out one by one functional dependency. First take out A determines B. Right? If I am going to take out A determines B, and you need to check out its validity. Validity means what? Even in the options of A determines B, can I able to get A determines B or not? You have to check. How can you do that? You can simply find out the A closure. What is the A closure from the remaining set of functional dependencies? AC, right? Can you able to get B? No. It means that there is some importance for A determines B in my set. So I should not remove this one, right? Like this you have to do for all kind of functional dependencies validity. Like for example, try to take out B determines C. Is this the valid one? Right? Is it compulsory required? Try to check. I will find out B closure. What is B closure without B determines C? B only. It means that B determines C also required for me, right? So that means it is valid one. And try to find out A determines C, right? If I am going to find out A closure, what you are going to get? A is compulsory, you will get. From A can you get B? From B can you get C? Yes. It means that A determines C can be possible in the options of A determines C. It means that it is not required. It means that I can say this is an redundant FD. So I can remove this one. Once I remove this one, what is your final set? A determines B and B determines C. Right? This is my functional set. Now what you have to do now? Once we modified some functional dependency in the given set, again you have to repeat the process because there is a chance to reduce it. So you can apply again the same procedure again and again, right? Meaning that after checking the validity, if you are able to remove any one of the functional dependency, right, repeat step 2. repeat the same step again and again, right? So this is step 2 you have to follow. And coming to the next step, in step 3, so guys, if you are able to observe, on the step 1 we concentrated on RHS side, on the step 2 we concentrated on both sides, that is like simply finding on redundant FDs, right? Redundant FD we find it on the redundant FDs. So what is the left one? We have to concentrate on the LHS side also, right? So that is step 3. So we have to concentrate on LHS side. So in LHS side we have to find out, so we have to focus on multiple left hand side attributes. What is the meaning of this one? If you are going to have a set of functional dependency contains AB determines C, so you have to check whether A can itself generate B or B can itself generate A, right? Meaning that in the options of A, can I able to get A with respect to B, right? So that is what I can say, the redundance, right? So if I am going to get B closure, if this B closure is going to determine A, then I can say that A is the redundant one, because B itself can able to determine A. Why we need to place again A there itself? So that's the thing, that's the concept, right? Similarly, in the options of, so you have to find out both case sum. In the options of B, can you able to get B from A, right? You have to find out A closure. If it itself is going to determine B, then you can remove simply B. If it is not going to determine, what is the meaning of this one? Both A and B are required. A plus is A, B plus is B, meaning that both are cannot able to get the respect to another one. So I can say that both are compulsory non-redundant attributes. That's it. This is what step 4. So once we done with all the things, finally you have to make it combine again, right? So you have to make the union of all FDs wherever it is possible, right? Where it is possible, basically wherever the union rule applies. Like for example, if I take A determines B and A determines C and some functional dependencies are there, right? So what you can get from here, A determines BC and some more functional dependencies you are going to get. So if you are going to follow this particular procedure, you can able to get finally the minimal set of functional dependencies, right? So basically we are going to simply concentrate on what are the attributes that may be redundant on RHS side, that is first step. What are the various kind of redundant FDs, that is the second step. What are the attributes that are redundant on the LHS side, that is the third step. Finally we are going to simply make it combine to make the less number of FDs. That's it.